Good evening. My name is Jeremy Hooper from MSAS 615. This is my field investigations portfolio artifact for structural and fire. Today I'm going to be discussing the air transportation of lithium batteries and the fire risks they pose to aircraft. These are the learning objectives that I will cover in this briefing. We'll discuss what happens during a thermal runaway of lithium batteries and what can happen as a consequence. Then we'll talk about what is happening in the air transportation industry that makes this a problem, along with the regulatory guidance intended to mitigate this problem. Finally, we will look at some of the specific National Transportation Safety Board recommendations and industry safety initiatives to reduce the probability that a thermal runaway of lithium batteries can cause a catastrophic mishap. I will start by running a short video clip of an FAA demonstration of what can happen when an air cargo shipment of 5,000 lithium batteries experiences a thermal runaway while inside a standard aircraft cargo container equipped with a fire suppression capability. The video begins immediately before an explosion within the container caused by the ignition of flammable gases emanating from the overheating battery cells. You can see a visible fire beginning at the base of the cargo container that spreads very rapidly as a chain reaction from the failure of one battery causes the failure and ignition of adjacent batteries and eventually the entire shipment. I think we can see where this is going. An uncontrollable in-flight fire that spells certain disaster for all on board by disabling critical systems and incapacitating the crew. Here's another look at what this might look like from up close. With such a large shipment of batteries packaged in close proximity to each other, you can easily see how quickly the fire can get out of hand. So, what exactly is thermal runaway? According to a research study conducted by Ontario Tech University, a thermal runaway is indicated by some form of mechanical, electrical, or thermal abuse, such as overcharging or applying an external force. It is an exothermic chain reaction that results in a sharp increase in internal temperatures that degrades the inner structures within the battery. This causes a short circuit that intensifies the electrical-chemical reactions, resulting in excessive heat generation and the production of flammable gases that dramatically increases the internal pressures, expansion of the outer casing, and possible explosion that repeats the cycle in neighboring batteries. There have been a number of total loss aviation accidents that resulted from uncontrollable in-flight fires in which lithium batteries were deemed the likely source. UPS Flight 1307 was a DC-8 on a domestic cargo flight from Atlanta to Philadelphia. On descent, the crew detected an unusual odor that quickly escalated into an inferno. The crew was able to evacuate after landing before the smoke and flames consumed them, but they likely would have suffered the same fate as the other two listed accidents had they not been in a position to land immediately. UPS Flight 6 and Asiana Flight 991 were both Boeing 747-400 cargo planes that also experienced uncontrollable in-flight fires, likely due to thermal runaway of lithium batteries. Unfortunately, both 747s crashed, resulting in the loss of all lives on board because they were unable to land quickly enough and the onboard fire suppression systems were unable to contain the fires. Now that I have your attention, the FAA has received reports of nearly 500 lithium battery incidents over the past 17 years, the vast majority of them involving passenger aircraft. These incidents clearly trended upward from 2014 through 2018. We saw a dip in 2020, likely due to the reduction in demand for air travel associated with COVID-19. But the trend in lithium battery incidents once again clearly trends upward as travel rebounds. Since the 2023 count only goes through October, it is likely the number of incidents this year will continue that upward trend by year's end. Why is this uniquely a 21st century problem that continues to grow worse year by year? This is mainly due to the rapid proliferation of commonly used personal electronic devices in today's society. Take a look at this chart and count how many of these lithium battery powered devices that you or your family own. How likely are you to travel with or ship these items across the country without much of a second thought about it? Consumer demand for keeping these products moving within our transportation system isn't going away anytime soon, so the question becomes, how do we transport lithium batteries safely? Fortunately, guidelines from regulators and industry trade groups are beginning to catch up to the threat. This simple chart from IATA provides guidance for shippers of lithium-ion batteries in 3 scenarios. On the left, we have limitations for batteries installed in their respective pieces of equipment. The wattage dictates the maximum weight of a package containing these batteries that may be accepted for shipment in passenger and cargo aircraft respectively. In the middle, we have limitations associated with transporting packages of lithium-ion batteries by themselves. Recognizing the danger associated with the level of charge of a lithium battery, note that these shipments must contain batteries that are charged to a maximum of 30% of their capacity and are forbidden in passenger aircraft. On the right, we can see the limitations that apply when the batteries are shipped along with the equipment that they're intended to be used with. Here's a corresponding chart from the FAA that provides a little more detail on labeling, proper shipping names, required shipping declarations, and additional notes. Similar guidance is available for lithium metal batteries, but is not shown here. These requirements mirror U.S. Department of Transportation and Pipeline and Hazardous Material Safety Administration regulations contained in 14 CFR Part 175. The challenge seems to be educating the public and shippers of hazardous materials of their responsibilities when it comes to transporting dangerous goods. A number of the accidents and incidents that brought this issue to light, including UPS Flight 6 in Dubai, involved incorrectly packaged or undeclared dangerous goods. Proper packaging to protect the shipment's contents, adherence to the limitations specified, and proper labeling with matching paperwork is key to ensuring safety when transporting lithium batteries and other hazmat. As this list of very recent incidents show, airline passengers need to be particularly aware of the dangers posed by lithium batteries contained within personal electronic devices and follow the guidance of the FAA, their air carriers, and onboard crew members. Fortunately, since large bulk shipments of lithium batteries are prohibited on passenger airlines, most of these events are isolated incidents in which the crews were able to extinguish the fires using emergency procedures to effect a safe outcome. It is also essential that passengers be educated to follow FAA guidelines and carry spare lithium batteries only in carry-on luggage and never as checked luggage. This enables personnel on board to quickly detect the presence of a thermal runaway and act to extinguish the fire. This is a capability that may not exist with inaccessible luggage. In the aftermath of the UPS Flight 6 accident, the NTSB made these recommendations to the FAA that are either considered open with satisfactory progress or were closed out with an unacceptable response from the regulator. In response to the open items listed, the FAA has issued multiple safety alerts for operators regarding lithium batteries, a number of emergency orders, and advisory circulars 120-80A and 121-40 that pertain to in-flight fires and dangerous good transportation. The NTSB considers the remaining 5 recommendations closed with unacceptable action, primarily due to the fact that the agency issued most of the guidance in the form of advisory circulars rather than regulatory updates. The NTSB notes that operators are not required to comply with advisory circulars and should be subject to the formal rulemaking process. The FAA claims a lack of statutory authority to regulate many of the asks from the NTSB. Despite slow action by the FAA to respond to NTSB recommendations, several key players in the industry have proactively implemented safety measures absent a concrete regulatory requirement to do so. For example, some operators are now equipping their aircraft with enhanced vision devices that allow pilots to see their flight instruments even if the flight deck is filled with smoke. UPS is testing new cargo bins that are capable of self-containing an intense fire for up to 4 hours. Delta Airlines has also equipped all of their aircraft with special fire retardant bags made by AFSACs that can effectively contain fires from small electronic devices typically carried by passengers and crew members. To summarize, today we talked about lithium battery thermal runaway and the threat they pose to aircraft. We discussed current trends in the industry and what may be behind them, along with the efforts to educate the public and shippers of hazardous materials. And finally, we addressed recommendations from the NTSB made in response to the crash of UPS Flight 6 in Dubai and other safety initiatives. This will conclude my structural and fire artifact submission for the MSAS 615 field investigation portfolio. I'll be happy to take any questions or feedback you may have.